Okay, so let us go to question number 3. So question number 3 is find the equation of the motion. Equation of motion, okay? Find equation of motion. So find the equation of motion. Okay, let us draw this. So give that weight 4.9 Newton, stretch the spring 0.9 meter when the weight and spring are placed in the fluid which resists the motion with a force equal to twice the velocity if the weight is brought to rest and give a velocity 20 meter per second. Find equation motion damping force 2V. Okay, so let us see. Okay, this is our fixed support, and then this is the, let's say this is the spring before it is giving a weight. Okay, so, and then after that this is the spring after giving the weight. Okay, after we give the weight here. Alright, so let's say this is the location of the spring and without weight, and then this is the location of the spring with the weight. Okay, after giving this weight, so this is the mass, and spring is we have the constant value of the spring, and then we have, when you put the weight here, it will stretch 0.49 meter. Okay, and then it reach the equilibrium like this. Alright, and the weight here is 4.9 Newton. Okay, okay, so this is, and after that this is equilibrium state, meaning, okay, so if they have no obstacle, mean this is no damping force, but in our case damping force here is we use the fluid. Okay, so meaning that this string, it will submerge into the fluid. Okay, so meaning that after that, okay, it will put into the fluid this one, the spring and this mass, and put the spring into the fluid, and look at that. Okay, so this is the spring stretch greater actually. Okay, stretch greater. So why is greater? Stretch great because in here okay, we draw like this. Should draw like this. Okay, after this spring is in equilibrium system, so now it's the same spring. Okay, this is the weight. Now we make it, meaning that if the weight is brought to rest and give a velocity 20 meter per second, meaning that this one we stretch this mass downward, okay, with the velocity 20 meter per second. Okay, all right, and then this one at the same time, this spring was, after you spread 20 meter per second, so now it is like this. Okay, so damping force, so it will submerge into a fluid. Let's say this is the fluid. Okay, say okay, here this is the fluid. So this fluid has a damping force. Okay, have a damping force, we call damping force. It's concept of like friction force. Okay, but here we call it damping force. So damping force could be fluid, it could be air, it could be some, like in mechanics, like absorber. Okay, absorber of the car. So all of this is damping. Okay, so this is damping force. So the damping force is equal to minus 2 velocity, 2 time velocity. Okay, so meaning that the if this mass is moving upward or downward, it will be have the friction. It will have the friction force like this. Okay, so this is the the y is when this mass is moving. Okay, so in y direction, and this y direction, it could be, this is, you can say that this is the limitation of this the motion. So meaning that it could be after you move in here, rest for a while, and then you know you move your hand. Let's say move your hand. So now the mass will go up, go down, go up, go down, go up, go down, go up, go down until it reach the equilibrium stage here. Okay, so this is y equal to 0. In here, y equal to 0. Means this is the place where the mass will rest in here. Okay, so this is the place, the motion of weight. So this is the motion of weight, meaning that this is the weight will move within this ring. Okay. Motion of weight. Okay, so if we break this force into pieces, you will get that. Okay, so this is force. So we can break this force into 3 force, like I explained last time, but I get some error in my explanation, so that I will correct it. Okay, so we have this force, which is gravity force. We have the spring itself, force, spring from the force, which is spring force, which is S. Okay, and then we have another one is a damping force, the fluid itself. So this is the damping force, Fp. Okay, damping force. So this damping force is okay, so this is damping force. So we take the positive direction is downward according to the movement of this spring. So according to the Newton law, we have, okay, Fg plus Fs, right, plus Fp, sorry, Fp equal to 0 according to the Newton law. So when we make this one as the magnitude, so we have Fg downwards minus Fs minus Fp, okay, equal to 0. And then we have Fg is equal to Newton law. Fg is equal to mass multiplied with the acceleration. Okay? Mass equal multiplied with the acceleration. So this is uh, the mass multiplied with the acceleration, and we have mass is equal to, okay, we have, okay, this mass is equal to, okay, force, because we have force, okay, so force is equal to, given the weight is 4.9, so usually F is equal to mg. Okay, so this is, I'm talking about the force of the mass. Okay, this is the force. This force doesn't have the it doesn't have the effect on the movement of the spring. So the effect of the movement of the spring is this force. Okay, but this force is on the mass when it stay in equilibrium. So it the mass is have like this. It really want to fall down. So that's why. So we got F is equal to mg. Let's say S0 here. S0 here. Okay, it's equal to mg. So m is equal to, okay, F0 divided by g, gravity force. So we got 4.9 Newton, okay, divided by 9.8, okay, meter per square per second square is equal to 0.5 meter, 0.5 kilogram, okay, kilogram, like this. So m equal to 0.5. So that's why we got Fg is equal to 0.5 y dash. This is referred to this one. Okay, so meaning that when the spring, when this mass is moving, so now you can imagine you drag this one about 20 meter per second. Okay, drag it, and then you release it. So now this release is equal to the force of the mass when you release is equal to mass multiplied with the acceleration of this item. Okay? So we are talking about when the mass is moving here. Yeah, when the mass is moving. Actually, this one is referred to when the mass is moving. When the mass is have a motion. Okay. Okay. So okay, we go on. So Fs, how about Fs? Fs is the force of the spring, right? So the force of the spring. So the force of the spring force spring. Okay, we got Kfs is equal to Ky. Okay, so Fs is equal to Ky, small k, little k. Okay, so equal to Ky. So Ky is what is it? K. What is K? So K is the constant of the spring. Constant of the spring. constant of the spring. So K is the constant of the spring. So meaning that it's equal to constant of the spring multiplied with the distance. Okay, the spring. So multiply with the distance. How much? How long? When you move down like this, so this length. So we move up with this length, this length, this length, this length. Okay, so but fortunately we have based on Hooke law. Okay, Hooke law, Hooke law force. Okay, Hooke law force. We have okay Hooke law force. So we have Hooke law force when the spring is in equilibrium stage. Equilibrium state. Okay. So we are referred to this one. Okay, this one, this part. So we refer to this one, this part. So when it in this, so I make it like Fs during the equilibrium stage. Okay, is equal to K multiplied with the X. So where is the X? Okay, K with the X. So this is X. So let's say X is equal to this one. Okay, K modified with X. So we have, so F now is equal to equilibrium equal to when F equal to the force, this force is equal to weight, okay, equal to 4.9 Newton, and X is equal to 0.49 meter. So that's why we can get the K is equal to F equilibrium divided by X, so equal to 4.9 divided by 0.49 right there. Okay, Newton right there. So equal to 10 Newton per meter. Okay, so this is a spring force. So we got Fs, so equal to 10y. Okay, and then for the damping force, Fp Fp for damping force Fp, uh, it is assumed to be proportional to the velocity. Okay, to the velocity, y dash is equal to dy dt. So that's why fp is equal to c cy dash. Okay, so it's, and c is a damping force, damping constant. Constant. Okay, so in our case, we have fp is equal to 2p. Okay, so these two, this is equal to each other. V dash, y dash and v, that's the velocity. So we got c is equal to 2. So that's why fp is equal to 2y dash. Okay, so in summation, we got fg equal to fs plus fp. So it will equal to 0.5 y double dash equal to 10 y plus 2 y dash. Okay, so we got 0.5 y double dash minus 10y minus 2, sorry, y dash equal to 0, or it's equal to y double dash minus 4 y dash minus 20y is equal to 0. Okay, so we let so should be okay now. Okay, then we can so y dash minus okay y dash where is one, okay, this one, g minus this. Okay, so y dash minus, so we have let, okay, y is equal to e lambda x. Okay, so we will get y dash is equal to lambda e lambda x, and y double dash is equal to square a lambda x. Okay, then we will get, replace this one, we will get lambda square a lambda x minus 4 lambda e lambda x minus 20 e lambda x equal to 0. So we got e lambda x, we got lambda square minus 4 lambda minus 20 equal to 0. Okay, so since our e lambda x is always cost different from 0, so we will get lambda square minus 4 lambda minus 20 equal to 0. Okay, then we have delta is equal to b square minus 4ax, so ac is equal to 4, so is 4 square minus 4 square actually, minus 4 square minus 4 multiply with 1 multiply with c minus 20. So we get such thing plus 18. Okay, so this is 96. Okay, 96. So square root of 96, how much? 4 point. Okay, so we will get the lambda 1 and lambda 2 is equal to minus b plus minus square root delta divided by 2a. So it will be equal to 4 plus minus 96 divided by 2. So we got lambda 1 is equal to 4 plus 96 divided by 2 equal, and lambda 2 is equal to 4 minus 96 divided by 2. So it's equal. Alright, so 4 plus square root 96 divided by 2. Okay, is equal to 6.9. Okay, lambda 2 is equal to minus is equal to minus 2.9. Yeah, 2.9. So we have, that's why we got y t here is equal to a e lambda 1 x plus b e lambda 2 2x, so it's equal to a exponential 6.9 x plus b e minus 2.9 x. Okay, alright, so this is our equation. Okay, so we got y is equal to a exponential 6.9 x plus b e minus 2.9 x sin, okay, so sin the weight started at equilibrium position with velocity of 20 meter per second. We know that y0 no y0 equal to 0, y dash 0 equal to 20 meter per second. Then we got y0 equal to 0 is equal to a 6.9 multiplied with 0 plus b e minus 2.9 multiplied with 0. So this one is 1, this one also 1. Alright, so we got a plus a equal minus b. Okay, minus b, and then we have y dash 0 is equal to 20 is equal to okay. Alright, so let us put it first. So we got y equal to a equal to okay minus b e 6.9x plus b e minus 2.9 x 2.9x is equal to e 6.9x plus e minus 2.9x. Okay, so we got y dash is equal to b 9.6.9 e 6.9x minus 2.9 e minus 2.9x. So y dash 0 equal to 20 equal to b 6.9 e 6.9 multiplied with 0 minus 2.9 e minus 2.9 multiplied with 0. So we have this one 1, this one also 1. So we got b multiplied with 6.9 minus 2.9, we got 4.9. Okay, so we got b is equal to 20 divided by 4.9. We got 20 divided by 4. We got 4.1. So our equation is equal to 4 point, sorry, 4.1 e 6.9x plus e minus 2 6.9 Okay, so this is the equation of motion of our mesh of our spring system. Okay. Okay, so number 4, exercise number 4, we continue tomorrow, inshallah. I need to verify a little bit. Okay, so see you tomorrow, and with the most difficult, the one of the difficult exercise in our tutorial. Thank you so much. See you tomorrow.